Hello, and welcome back to Vector's All Things PC-lint Plus YouTube series. Once again, I'm Jacob Colapietro, a field applications engineer here at Vector. This is part 3 of the series, where we will be covering some additional PC-lint options that you can add to your setup. In the last video, we discussed the process for creating a project configuration file for your setup, so go check that out if you'd like to know more about that topic, and let's get started. So before we get started, I just once again wanted to briefly discuss the requirements to run PC-lint in its most basic capacity. So what we've learned over the past 2 parts of this series is all that's needed to run PC-lint is the compiler configuration and the project configuration, which will contain a list of source files. So with these 2 things, you can run PC-lint and get some really in-depth and meaningful analysis. However, with PC-lint, that's just the tip of the iceberg. There's tons of additional options that you can use to tailor your PC-lint analysis to find exactly what it is you're looking for. So you can do plenty of different things like enable coding standards, change the format of your PC-lint output, and even generate stack and metric reports. And the best part is all of this is relatively easy to add and can be done very quickly. So today we're going to be going over how you can add this options indirect file to tailor your PC-lint output and see exactly what it is you want to see. All right, so I've once again moved over to VS Code. Since our last video, I've just touched up our script a little bit just to enable me to call it with either imposter or the compile commands JSON setup that we worked on in the last video. Just that way we can support both at the same time. We still have that same general flow of create compiler configuration, then create the project configuration, and then run the analysis. We're just able to support either project configuration option now. All right, so how do we go about adding these additional options? Well, if we remember back to the first series overview video I did for the series, I mentioned that indirect files are files that can be used to contain multiple PC-lint Plus options. Well, funnily enough, our compiler configuration and our project configuration are both indirect files that contain multiple options. So what I like to do for my PC-lint setups is to create a specific options indirect file to use for any option I want to add. So I've created this file called options.lnt here. And before we jump into writing this file, there's a couple things I'd like to mention. The first is when writing indirect files for PC-lint, so any of these .lnt files. White space does not impact how options are read from this file. So it doesn't matter if every option is on the same line with a space in between them, or if there's an option and then 10 new lines in an option. White space doesn't impact how they're read. The next thing is section 4.2 of the PC-lint manual has an options reference. So if you're interested in looking at more options that are available to you or getting more information about the options we discussed in this video, go and check out section 4.2 of the PC-lint manual. All right, so we have our additional options file here. So the first option that I've added, as you can see on line 1, is minus max threads equals 15. So this is the first option that I think everyone should add to their PC-lint setup. And it just allows us to set the maximum number of threads for our analysis. And this is just a very easy way for us to significantly speed up our PC-lint analysis. So I think this is a very easy first option for everyone to add to their PC-lint setup. All right, so we've added more threads to our PC-lint setup, which will significantly speed up our analysis. So I've mentioned quite a bit that we are able to suppress messages from PC-lint. So there are multiple different ways that we can do this. And I can't stress that enough. There's more ways than I can go over in one video to suppress messages from PC-lint Plus. So the key part that I want to point out is that each PC-lint message comes with a certain code number. And I would say that this is the primary way that you can easily suppress a message from your PC-lint output. So we have this terminal output here from running the analysis using our script. And if I just scroll through this output here, you'll see that each message has its own numbers. So we have 769 here, 765, 1714. So anytime PC-lint outputs a message, it'll have a code number with it. So if we want to suppress a message just in general from PC-lint, we can just use this -e option. So I've done that here. We do -e and we'll do the 769 option or message. So as I said, there's multiple different ways you can do this. Another way is -e lib, and then you provide it the number of the message. And this will just suppress message 769 for any of our library code. There's a -e type, where you would provide the message number and the name of the type for PC-lint. There's -esim, which same thing, you provided the number and then the name of the symbol. And also there's -efunc. You could give it the name of a function, so name of func to enable that message for specific functions. So like I said, there is a ton of different ways that you could do this for PC-lint Plus. I actually cannot go over all the different ways that you can do this because there are so many. What I would recommend is if you're interested in seeing more ways you can do this and how to actually lay out the format of the option, then check out the PC-lint manual, specifically section 4.3.1. It's titled Error Inhibition. And that contains a lot more information about the different suppression options and how to actually use them. So that would be very helpful if you're interested in seeing more about message suppressions. I'd also be sure to read our SCA doc, which is also in the doc directory along with the manual, just before suppressing anything if you're working on a safety critical application. There's some general recommendations and considerations in there with regards to message suppressions that I think would be good to read and go through before you start stripping out any PC-lint output you may get. So these are multiple different ways you can do this. Again, there's probably double the amount of options as this, if not more. But for the purpose of our options file, I'm just going to keep it to the -e and -e lib for the 769 message. And we'll see a difference in the output that we won't see the 769 message once we run the script again. Yeah, so those are some different ways that you can suppress messages with PC-lint. All right, so we've seen a couple ways that we can suppress PC-lint output. What can we do next? Well, I think the most important thing would probably be coding standards. So I've mentioned before that PC-lint has many coding standards available to it that you can choose from and specifically tailor your analysis to. So if you're interested in seeing all of them, you can just navigate to this LNT directory underneath your PC-lint install. And so as you can see, we have a lot of them. There's a bunch of different MISRA options. We have CWE here, as well as a couple AUTOSAR options. So any of these AU- files, they're called author files, are a different coding standard that you can tack into your PC-lint output. So how do we enable these coding standards? Well, it's actually pretty simple. So in our options file that we just made, all we need to do is include one of those files. So there are a couple ways you can do this. The first is to use the fully qualified path for the standard file that you want. I don't use that way because I think it's a bit messy, especially if you want to include multiple standards. So what I do is what I did on line 9 here. I just include that directory, that LNT directory that we were just in. So if you remember, I set up this PCLP_dir environment variable in our batch script, as you can see here on line 2. And the syntax for including that in one of these LNT files for PC-lint is the same as it is on Windows. You just do a % and a % and then the environment variable. So this -i means include this directory. So we've just included that LNT directory. So then all we need to do below this is add the name of the file. So I'm going to do the AU MISRA -cpp2.lnt. So now this MISRA coding standard will be additionally checked on top of our regular PC-lint Plus analysis. So if we want to do CWE, it'd be the same thing, just the AU-CWE.lnt. And it's the same for any of these coding standards. So now that we've included this directory, we can add any of them that we want. So I'll just leave these two for now, but you can go through and mess around with any of the different coding standards like AUTOSAR or the MISRA C if you want. All right, so we have some message suppressions and we've enabled a couple coding standards. So what else can we do? Well, I don't know about you guys, but I don't particularly like the look of the output here in this terminal window. So how can we format it differently? Well, luckily for us, there are multiple different formats that PC-lint provides that we can use. So if we once again go into that LNT directory where we're looking at all the coding standards, you'll notice 3 files here at the bottom prepended with env dash. So these files just enable us to reformat the output from PC-lint Plus. So you'll see there's one for XML, one for HTML, and then there's also one specifically for IAR. So you can also output to a text file, but you don't need this env dash file. You can just do that. So for this video, I'm going to do HTML output, but these other outputs will follow the same methodology. I'm just going to be using this html.lnt file. So how do we set this up? Well, there's 3 things that we need. The first is to include that LNT directory. We've already done this here on line 9 when we were setting up our coding standards, so we don't have to do that again. But if you haven't done this yet, you'll have to do this -i and include that LNT directory. So the next option we need is -os. And then brackets. And within the brackets, we are going to provide a file name. And since I'm doing HTML output, mine's going to be with the HTML extension. So I'm going to do lint_results.html. And this just tells PC-lint we want to output all of the findings to an HTML file called lint results. So the next thing we need is to include that env dash file. I like to put these 2 options on the same line because they kind of go hand in hand for reformatting the output. But you could put them on different lines. Like I said, white space doesn't matter. It's just my preference to put them on the same line. So now I'm going to do the env-html.lnt. And so with all of this, it's going to tell PC-lint to output in the format of an HTML, and all the output's going to go to this HTML file. So once we run this script again, we're going to see a file that gets output to here called lint_results.html. And we'll be able to go into our file explorer and double click on it. It'll open a browser for us, and it'll have the results formatted a bit more nicely. So again, if you want to do XML, if you want to do text, you could follow the same process and you'll output to a file, an XML file or a text file. So that's the way we can set up a different formatting for our PC-lint output. All right, so the last bit of options we're going to go over for this video is different metrics that we can enable. So the first is just an overall metrics report. And this metrics report will contain valuable information about your program, and it can be used to enforce different coding guidelines or measure code quality. So there's a wide variety of statistics that are available in this report. So I definitely check this out. So there's things like different Halstead metrics, cyclomatic complexity. You can check the number of statements in a file, things like that. So to enable this report, all we need to do is add the option plus metric report. And there's going to be a few input parameters for it. The first is scope, and I'm going to be setting it to all. So the default value for the scope is all, and that just means we're checking all of the metrics. However, you can set this to nominated, and with nominated, you nominate certain metrics to show up in your report. So the next option is format. And here you just specify the output format for the metrics report. The default value for this is CSV. I'm going to also be setting this to CSV, but you can alternatively set it to XML or JSON. So the last option is file name. And as you can guess, this is just where we specify the output file name for the metrics report. So for this, I'm just going to do metrics.csv. So with that, we're going to output a metrics report. But you can also add filtering to the metrics report. So say you only wanted to see functions cyclomatic complexity if it's less than 5. Well, all you need to do is add the plus metric option. And within this, add function dot cyclomatic underscore complexity less than 5. So this will filter our metrics report and only show us the cyclomatic complexity for functions if it's less than 5. You can add any filtering for any of the metrics in here. So number of statements, like I said, all those Halstead metrics. This is a great option to filter all of those. With this option, you also nominate metrics. So if you're using that scope equals nominated, you'll use this option for that. So the next option I wanted to show off from that kind of metrics perspective is a stack usage report. So this report is just going to contain worst case stack usage for each function within your program. So to enable this report, all you need is the plus stack option, and it's going to have one input parameter, and that input parameter is &file. And this is just where you specify the output file name for the stack report. So I'm just going to do stack.txt, and this will just indicate that stack usage report should output to stack.txt. So now this will generate a full worst case stack usage report for our PC-lint setup. All right, so with all this in place, we have a full options indirect file. So in this file, we've done a number of things. We've increased the number of threads to our PC-lint setup to increase the speed of our analysis. We've gone over a couple message suppressions, how to enable some coding standards, changing the output format of our PC-lint output, and adding some metrics. So we have a pretty fleshed out options file here for our PC-lint setup. I'd like to point out that this is just a few options that I'm showing here. These are options that I find myself using the most. However, I really can't stress this enough, there's tons of options available to PC-lint. It's a very customizable tool. So please check out the manual, section 4, and more specifically, section 4.2, to see all the options that are available for you for this type of file. All right, so we have our options file all set up. Well, how do we use it with PC-lint? Well, we just basically tack the options file on to our PC-lint execute command that we were using previously. So I've already set that up on line 34. So we're calling PC-lint with our compiler configuration, have our options file we just created, and then our project configuration. So I've already taken the liberty of running the script. And one thing you'll notice over here is we have 3 new files, the stack.txt, our metrics.csv, and our lintsresults.html. So one thing you'll also notice is we have no PC-lint output here in this terminal window, and that's because all of it was sent to this lintsresults.html. All right, so I'm just going to walk through these files briefly just so you can kind of see what to expect on your end. So we have the stack.txt, and you'll see we have all of the functions listed out here. So we have the function, the amount of stack usage for that function, and the total stack usage for that call tree to get to that function. And we also have the callee function. So this is a great file for you to use if you're interested in seeing some stack information. You know, maybe you're limited on stack space, so you want to make sure you're staying within your means. So this is a great file to use if that's a situation you're in. So next we have our metrics file. And what you'll see here is we have project level metrics, so number of distinct files, number of messages, the number of each message from the PC-lint output. So number of 762 messages here. Each PC-lint message will have its own metric to go with it. And if we scroll down, we have translation unit, file, and then we'll have function level metrics. So there's a ton of information in this file. So a great one to use if you're interested in seeing a bit more about what's going on in your project. So the last one is the lintsresults.html. So all of our PC-lint output, instead of going to that terminal, is now here. And one thing you'll notice if I just start scrolling through this is we have significantly more output than we had before. And that's because we enabled those coding standards. So what you'll see is we have MISRA C++ right here. So if a MISRA standard is violated, we'll get a output message from PC-lint. We also have those CWE messages that we enabled. So there's a bunch of those in here as well. And another thing I want to point out is we set up that cyclomatic complexity filter. And if PC-lint goes through and finds a function with a cyclomatic complexity that's less than 5, as we set up, then it'll output a message here in our PC-lint output. So we have a bunch of those here. So the last thing I wanted to point out is in our options file, we tried disabling message 769. So those show up as info space 769. So we suppress those, but they're still showing up here. Why is that? I actually didn't know this was going to happen before I set this up, but I think this is a good little learning experience. So in our options file, we have minus 769. So I mentioned previously that PC-lint options are read sequentially. So PC-lint went through and saw our minus E769 option. So it was going to enable that message. But afterwards, our au-cwe.lnt file, within that, you see there is a plus E769. That means that our CWE, after the message was suppressed, went ahead and enabled the message again. So now, in our results, we are still getting that message. So that's just something to be aware of if you're including these coding standards, that if you're suppressing a message, you might want to do it after the coding standard if you really, really need that message suppressed, just because it could be re-enabled if you're including some of those coding standards. So to recap today, we went over multiple options that you can add to your PC-lint setup. These range from different coding standards that you can enable to adding more threads to speed up analysis, or even different metrics reports that you can generate. I'd once again recommend that you check out sections 4 and more specifically 4.2 of the PC-lint manual. Here you'll find a more exhaustive list of the options that PC-lint has available to it. As I mentioned before, PC-lint has tons of options. It's a very customizable tool, so I definitely recommend that you check out this section to find exactly what it is you're looking for. Please also remember to tune into the next video where we'll be going over different IDE integrations that you can do with PC-lint Plus. I'll be going over VS Code as well as Eclipse IDEs. Thank you once again for watching and have a good one.